So your homework from last week was to complete the lab on pH, which was, I believe, lab 17. Or lab 11. Let me just check it out. Yes, it was lab 11 last week. You had to finish lab 11 and send me your data tables and the answers to your questions. Today, we are going to do lab number 12. Now, lab number 12, you need your kit, and then you need two more things. You need a piece of plain white background, and you are going to need some vinegar. Before we go ahead and do that, though, we are going to go ahead and talk about molarity. Raise your hand if you've ever heard of, or have any idea what molarity is. Anyone? No? Perfect, then we've got a lot to cover today. All right, so molarity is a big chemistry word. I have it up on your PowerPoint screen right now. Molarity and dilution. It is sort of a measurement. Ethan, good try. It's a concentration. So molarity is the concentration for a solution. It's the moles of solute in a liter of solution. When we're talking about molarity, and I used it at some points during this PowerPoint, scientists, chemists, use a capital letter M, and that is the symbol for molarity. So basically, when you are talking about molarity, you are talking about the amount or the weight of a substance in a liter of solution. So for example, if I told you I need a 1 molar solution of sodium chloride, you would figure out that you would need 58.5 grams of sodium chloride, which is 1 mole. That's a given. That's a number that I would give you. And then you add water to it to make a 1.0 liter of solution. So in the the two steps are right here for you. You would take a flask and you would weigh out 58.5 grams of sodium chloride. Then you would add enough water to that solution to make 1 liter. So you may not add 1 liter of solution, or you're not going to add 1 liter of solution, because you need it to add up together to equal 1 liter. There are 4 steps to calculating molarity. I would go ahead and jot this down on a scrap paper because we are going to refer back to it a lot today. So take a minute and jot these down, please. And then once you have the 4 steps written down, please click yes. I want to make sure you guys have this down on your paper. All right, remember, once you are done, please click yes so I know everyone has this written down in their notes. Okay, fantastic. Perfect. The first couple we are going to work out together. So here is an example of calculating molarity. What is the molarity of a 0.5 liter sodium hydroxide solution if it contains 6 grams of sodium hydroxide? Well, I am going to give you 6 grams of sodium hydroxide in 5 liters of solution. That is our given. The first step tells you to state the given quantities. Easy enough, it tells us that in the problem. Everyone should be able to get step 1. Now I also added what we need. We need to find the molarity, or the moles per liter, of sodium hydroxide. Okay. So step 2, write a plan. So we need our plan. Our plan is to change grams of sodium hydroxide to moles of sodium hydroxide to molarity. That's step 2. That's our plan. Step 1 and 2 require absolutely no calculations. It is setting your problem up for success. Raise your hand if you have a question on steps 1 or 2. You're setting yourself up to succeed. All right, so let's go to the next step. Step 3 and 4 are on this page. Now, step 3 says write the equalities and conversion factors needed. Okay? I'm going to give you 1 mole of sodium hydroxide equals 40 grams of sodium hydroxide. Easy enough? We've got that. Now I need to write my conversion factors. There are 2 conversion factors for every problem. Then you are going to decide which one you need based on what you are trying to find. So my conversion factors is 1 mole over, and in this case we have sodium hydroxide, 1 mole of sodium hydroxide over the number of grams. A mole of sodium hydroxide is equal to 40 grams of sodium hydroxide. So we place them over each other. Now the opposite is also true. 40 grams of sodium hydroxide is equal to 1 mole of sodium hydroxide. So we can write that conversion factor as well. Now we need to set up our problem to calculate molarity. Step 4 is truly the only part of this that you are actually going to do any calculating. So we know that we have 6 grams of the sodium hydroxide, and we know that there's 1 mole of sodium hydroxide for every 40 grams. So just like when you're converting feet to inches or meters to centimeters, we have to make sure that our labels cancel out. So if we want to make the grams of sodium hydroxide cancel out, because we are trying to find the number of moles, which is what we said our first step of our problem is, we need to use the first conversion factor we had up here. So we will do 6 grams of sodium hydroxide times 1 mole of sodium hydroxide over 40 grams of sodium hydroxide. And we will get 0.150 mole. 6 divided by 40 equals 0.150 mole. But we're not done. That's the first part. Now, we said the second part of our problem was to change the moles of sodium hydroxide, which we now have, to find molarity. Well, we have to think, what is molarity? Molarity is moles over liter. So we have 0.150 moles, and if we look back at our original problem, which I know you don't have on your screen anymore, but the original problem said there was 0.50 liters of sodium hydroxide. So we are going to do 0.150 moles divided by 0.50 liters. When you do the division, you get 0.30 moles per liter of sodium hydroxide. Moles per liter is molarity, so our answer is 0.30 molarity sodium hydroxide. So, we are going to look at another one. Here is your problem. What is the molarity of a solution if 325 milliliters of the solution contains 46.8 grams of NaHCO3? What I want you to do is set up your step 1, 2, and 3. For step 3, you need the information I am putting in the text chat. 1 mole of NaH. CO3 is equal to 84 grams of NaHCO3. So go ahead and on a scrap piece of paper, work your way through steps 1, 2, and 3 of this problem, please. Okay, once you have worked your way through steps 1, 2, and 3, click yes or click stuck if you are stuck, please. Okay, great. I am not expecting you necessarily to be getting these right. Eventually, I would love for you to get them right. This is something you're going to need as you further yourselves in chemistry. However, what I'm doing now is just kind of introducing it to you and setting you up, hopefully here, setting you up for success in the lab. So let's take a look and see what we have. Here are steps 1, 2, and 3. Step 1, you probably all got without any problem. You wrote your given. You were given 46.8 grams of NaHCO3. And you also knew that we have 325 milliliters, which is the same as 0.325 liters of NaHCO3. Now we need to get our plan. So we need to think back, and we have our plan, and our plan is we have the grams of NaHCO3. We need to get moles of NaHCO3, and we need to find the molarity. So that is our grand plan. We then need to, in step 3, write our conversion factor, and that's the numbers that I gave you in the text chat. Your conversion factors will always be moles over grams and grams over moles. So it doesn't matter which one you did first at all. One mole of NaHCO3 over 84 grams of NaHCO3, or 84 grams of NaHCO3 over 1 mole. If you got stuck, or what you had on your paper was incorrect, please on your paper right now, make sure you write down the correct plan, the correct conversion factors, and the givens. I know you may feel like it is silly, but if you write it, it's easier for you to remember it. Go ahead and click yes when you are ready to move on. Okay, make sure you click yes when you're ready to move on. All right, I'll give you one more minute to finish copying it down. Those of you still copying. Okay, so now let's think about what we would do in step 4. Step 4, you need to set up the problem. Your problem, first, is you need to calculate the grams of NaHCO3 in moles of NaHCO3. So we know that we had 46.8 grams, and we know that there's 1 mole per 84 grams. So that's the equation factor we are going to use first. So let's take a look. We are going to use 46.8 grams of NaHCO3 times 1 mole of NaHCO3 per 84 grams of NaHCO3. You do 46.8 divided by 84, and the answer you get is 0.557 moles. That's the first part of our problem. Now we need to look back at our givens. And the next part of our given is that there were 325 milliliters, or 0.325 liters, of NaHCO3. So we are going to divide 0.557 divided by 0.325. We get 1.71 moles of NaHCO3 per 1 liter of NaHCO3. We put the right or the correct label, and we have 1 molarity NaHCO3. Go ahead and answer this quiz for me. Okay, we're going to go ahead and try another one. What is the molarity of KNO3 solution if 225 milliliters of the solution contains 34.8 grams? Okay, I will give you the conversion factor in the text chat again. go ahead and try to get as far on this problem as you can. Make sure you write out your steps. Okay, so let's take a look. Go ahead and check your answers with mine. we are going to start with step number 1, which is given 34.8 grams of KNO3 and 225 milliliters of KNO3. What do we need? We need the molarity of KNO3. And now we need our plan. Our plan is grams to moles to molarity. Okay? So it should be pretty simple for you guys to figure out. Now you wrote your 2 conversion factors from the information I gave you in the text chat. Your 2 conversion factors were 1 mole over 101.1 grams and 101.1 grams per 1 mole. Then we set up our problem. Now this is the tricky part. We had 34.8 grams, and we're going to multiply it by 1 mole per, or over, 101.1 grams. So our answer is 0.344 moles of KNO3. Then we have 0.344 moles is our answer. And remember, we're looking for molarity, which is moles per liter. So for our moles per liter, we do 0.344 divided by 0.225 liters. And we end up with 1.53 molar KNO3. Now, if you're fancy, you can set this up all as one equation and combine it all. And that's what I put on the bottom here. I even still, most times, set it up as 2 separate equations. It just makes it easier for me to keep everything straight. Now, I realize you may not be completely comfortable with that yet. I realize it's not, your ideal just going through 2 problems. I am going to put my PowerPoint up on the website at the end of class, and it has probably about 5 or 6 different problems to look at. So if you're not comfortable, go ahead and take a look at the website at the end of the class. What we are going to do now is we are going to switch gears, kind of completely, kind of not completely, and we are going to go ahead and look at our lab for the day. The lab for today, I believe, is lab number 12 on page 65. Go ahead and get your lab book out, please. You are also going to need, for this lab, vinegar, and a piece of white paper. I need to go grab my vinegar. Once you have everything for the lab out and ready, click yes.